Okay, there we go. If you notice, the essential question says, give 2 examples of 2 independent events and 2 examples of 2 dependent events. So by raising a hand, can anyone think of two events that are independent of each other? 2 events that are independent of each other. Okay, so be a little more specific. You said sports and math. I need an event of some sort. What about sports is independent of math?
What about cooking and...
I'm sorry. Nope. We have one person responding right now. It is not you. Sorry. It escapes. What about football, though? We need specifics. Could we say football practice versus math class? Because can you be in both at the same time? There are some statistics and there's numbers in football. There's a relationship of math and football. But physically being in football practice and physically being in math class are independent, right? If you show up to math class, that has no influence on if you show up to football practice. If you show up to football practice, it has no influence on if you show up to math class, right?
Yeah, you can't play unless you go to class.
Well, you can't play unless you're passing, right?
Still.
So so with your ability to play the game, there is some influence. So independent events. Example, ladies and gentlemen, you can talk about holidays after 2:10. Right now we're doing a lesson on probability. Okay, independent events are 2 events where the outcome of the first event does not affect the outcome of the second event. Okay, I heard Victoria actually say, I'm independent. Do you guys feel like you're independent?
I would die without my mom.
Oh, so you're actually dependent on your mom.
Dependent on my mom.
So the government actually agrees with that. Because most people, unless there's some rare situation, I'm assuming, most people, when your parents file their taxes every year, by April 15th you have to file taxes, they claim their children, you guys, as dependents. Because you still need support from them in some way. They're probably paying for the rent or paying the mortgage of some sort to provide a house for you, right? Okay. Babies definitely are independent, right? Can a baby get in a car and drive themselves to the grocery store to go grocery shopping? No. Babies definitely are dependent. And as you get older, you're feeling more independent, but you're still a little bit dependent on those adults. Right? When I turned 22 was the first time I got off my parents' taxes because I had my first full-time teaching job, right? And I was, so with a full-time job, you also get your own benefits, which means health insurance, dental insurance, stuff like that. So when I was 22 was the first time I started filing my own personal taxes, which meant my parents could no longer claim me as a dependent. Then I claimed myself as an independent. Okay, so, and another example of, oh, we'll do this one in a sec. Let's write down what a dependent event is. Dependent event. Like I mentioned, you guys are dependent on your parents because you rely a little bit on your parents. So, dependent events, 2 events where the outcome of the first event affects the outcome of the second event. Two events where the outcome of the first affects the outcome of the second event. Okay, erase your name, Mo. Thank you. I hope you did well. Okay, so in my hand, I have a deck of cards. Took out the jokers, 52 cards, like our usual deck. If I was to draw twice, okay, so here's my first draw. Looks like I got 6 of diamonds. Now for my second draw, if I put this back in, does my second draw have any influence from the first draw? Because my second draw, since I put the card back in, that's called with replacement. I put the card back in. Does my second draw start with the same number of cards that I could possibly draw?
Yes.
Yes, so the scenario has not changed. It has the same scenario as the first scenario. So this would be an independent event. So if I draw a card, ace of diamonds, I place it back in. This is called with replacement. And I draw again. Those two events are completely independent of each other. Okay, but if I do it differently, I hope you're paying attention instead of playing with calculators. If I draw a card, Queen of Spades, right? That's the spade, yeah. And I put the Queen of Spades on the table, what? And then I draw my second card. Is this independent of my first draw or dependent on my first draw? The I or the D? The D, because I put my Queen of Spades on the table. It changes my scenario for the second draw. I no longer have 52 cards. I only have 51. And if the second draw, I was looking for that Queen of Spades, I have a slight problem because it's not in my hand anymore. It's on the table. This is called without replacement. Okay? Here I have a die. I have a die. Actually, let's do 2, just for fun. I have 2 die. Okay? First roll. Let's roll it this way, please. Second roll. My 2 rolls, I actually did get snake eyes, wow. My 2 rolls, were they independent or dependent of each other? I or D, because the words kind of sound the same to me. I or D? I. Because my first roll, I had all 6 possibilities. My second roll, do I still have all 6? Even if I use the same dice. First roll, second roll, does the second roll still have all possibilities? Yes. So, that's an example of independent events. Okay, so, good. Any questions on the differences between independent and dependent? Yes?
It never goes in the reverse. The second one doesn't affect the first one,
Not for today. Next lesson we'll be doing conditional probabilities, which is this event given this first event already happened, and you can change the order. So next time that will come into play. Okay, so we've already written those. Now, in statistics, it's important for you guys to remember the following. Please write this down. In statistics, and means, not today, multiply. And means multiply. If you hear the word and you're working in statistics, you should automatically think multiply. But if you hear the word or, you should think add. Okay? In statistics, and means multiply, or means add. Okay? So there's a formula with probability given two independent events. We have to know that they're independent of each other. If you were to find the probability of event A and event B happening, if you were to find the probability of event A and the probability of event B happening, what does the word "and" tell you we should do with our individual probabilities?
Multiply.
Exactly. Multiply. Probability of A times the probability of B. Okay? You'll essentially, I think, be given 3 formulas total today. So please make sure you have these formulas written down. Probability of A and B, both events happening. And means both have to happen. It's an overlap. If you were to draw a Venn diagram of A and B, here is A, here is B. Who can explain to me or describe for me where A and B would be? Phoenix? The middle. So it's the overlap. A and B means they both have to happen together, so it's the overlap. Because a Venn diagram shows, like if this was the numbers 1, 2, 3, 4, 5, 6, 7. Okay. What's the probability an event A and B means it has to fall in circle A and circle B. What number is only in circle A and in circle B? 5. So Venn diagram is just a visual to see what it means to be and. Okay, we'll do or in a minute. Okay, so those have to be independent events. So for our first example, I want you to look around the room and count, please, how many male students do we have? Okay, Tristan's moving, so, Jared's coming back in. I guess we'll have to wait. Guys, find a seat, please, so, because people are trying to count bodies, so it's easier if bodies aren't moving.
14.
That wasn't nice. 5, 6, 7, 8, 9, 10, 11, 12, 4, 5, 6, 7, 8, 9, 12, 13. Okay, yes. Okay, now please count up how many female students we have. Female students, please. 4, 5, 6, no, 8, 9, 10. I thought I counted 10. Oh, okay, Tristan and Raul, I need you to sit down. It makes it really hard to count when people are moving. Please sit down. 2, 3, 4, 5, 6, 7, 8, 9. I'm counting 9. Are you counting yourself? Yeah, count yourself since you are a girl. Okay, I said students though. Okay, 14 plus 9 means how many students are in this class? Let me be more specific. 14 plus 9, when you add them, how many students are in this class? 25. 23. Just testing you. You did trick me. Alright, so if we were to put in a bag, shake it up all your names, and draw twice. We have to have 2 names. And let's see, say event A is that we draw a male name. Event B is that we draw a female name. And pull out 2. What's the probability that we would draw Probability of A and B happening. Oh, careful. Probabilities aren't just integers, though. We can write probabilities in 3 forms: fractions, percents, or decimals. Okay, so event A is male. What's the probability that we would draw a male name? 14 out of 23. We put it back in because it has to be independent, right? With replacement, put it back in. Awesome. Shake it back up. What's the probability that we draw a female name? 9 out of 23. And we have to simplify that. Okay? So, I hope you've already picked up your calculators. Clear. Who has the laser pen? I can happily get an administrator in here.
I got it.
Raul, you need to sit down. No, you may not. You've been out of your seat at least 4 times already this class. Please sit down. Let's type in 4 divided by 23. I put parentheses. There's different ways you can do it. You can do 4 times 9 and then 23 times 23 and form your fraction that way. Or you can do it in parentheses like I'm doing. Times in parentheses 9 divided by 23.
14.
Oh, it's not 4, it's 14? Okay, let me fix that then. Are there really only 9 girls? Wow.
Lovely, man. They need to get to class.
Oh, well, that's not very nice. You can leave if you're not going to be polite to people. Oh, my calculator's not working anymore. It's frozen. All right, I'm just going to have to do it on a regular calculator because that calculator's not working. So, 14 divided by 23 times 9 divided by 23. Okay, 24%, or if you still have that decimal up, would you hit math, enter, enter for me if you still have that decimal? Math, enter, enter. What's the simplified fraction?
126 over 500.
No. Great, so 126 over 529, which you already told me was approximately 24%, and 24% actually makes more sense in our head than this weird fraction. Okay? Okay, example 2. In your desk drawer, you have a bunch of pens. You have 5 red pens, 6 blue pens, 3 black pens. 5 red, 6 blue, 3 black. You also have a bunch of paper clips. Whoa. Okay, you have 24 silver paper clips, and white paper clips you have 16. Right, please. Okay. Please write your notes.
I'm not going to write it all over again.
Start where we are. There's a thing called a stapler. You can staple them together. Okay, let's find the probability that without looking, see where am I? If you select a pen and a paper clip from the drawer without looking, what is the probability that you select a blue pen and a white paper clip? So probability that we get a blue pen and a white paper clip. Are these events independent? Because our formula only works if they're independent. Is the pens separate of the paper clips? Yeah, if you pick a blue pen, it has no reflection on what paper clip you get. Pens are in their own family, paper clips are in their own family. So, probability of getting a blue pen. Raise your hand when you know that probability. What's the probability of getting a blue pen? Tristan? 6 out of 14, because there are 14 pens. Okay, raise your hand if you know the probability of getting a white paperclip. A white paperclip.
That's 40.
Okay, raise your hand.
Oh, my bad. Alright.
Victoria? Thank you. Now, the word and. Evelyn, I see the word and here, so what do we do in statistics when we see and? Excellent, thank you. Now these fractions, I know first off that they're all even, so it's easier to work with small numbers, so I'm going to simplify them first. 6 and 14, since they're even, are divisible by 2. Okay, Alejandra, if I divide 6 and 14 by 2, what fraction would I get? Do it in your head. 6 divided by 2? And 14 divided by 2? That's 12 divided by 2. So 14 divided by 2. There you go. We're going to times that by, let's simplify this one. 16 over 40. Teddy, what number divides into 16 and 40? 2 does. I agree with that. There's actually a bigger one. There's 2 bigger ones. What's the biggest number we can divide into 16 and 8? Okay, so what's 16 divided by 40? What does that simplify to if we divide 8 into both of those? 16 divided by 8? Those? E? No. No. Oh, yes, C. C. I was thinking it was 8. Okay. I Spanish it. All right, 3 times 2 we know is 6. 7 times 5 is 35, so there's our fraction. Divide that, please, so we can understand what this probability means. I think percents are easier for us to understand. 3 times 2, though, is yeah, just 6. 17%. Okay, 17% probability that you'd pick a blue pen and a white paperclip. Again, this is off of independent events. 2 independent events. If we see the word and, we multiply. Any questions on independent events and probabilities? Good? Okay, let's go on to another thing in statistics called mutually exclusive. Mutually exclusive events. Mutually exclusive events are 2 events that cannot occur at the same time. 2 events are mutually exclusive if they cannot occur at the same time. 2 events that cannot occur at the same time. 3. 2 events that cannot occur at the same time. So, this is not the one I wanted. Here we go. Student athletes at a local high school may choose to participate in only one sport for each season. Okay, so can they play on 2 different high school sports teams? No. So these are mutually exclusive. Here's a Venn diagram again. Mutually exclusive means event A has to be completely separate from event B. They're not overlapping. They can have no overlap whatsoever. So, given that athletes can only play on one sports team each season, athletes can only play on one sports team each season. And we know that, let's see, 28% of students play basketball. 28% of athletes, I should say, not just students, play basketball. and 23% of athletes are on the swim team. So once again, can you be on both the basketball team and the swim team? Not in this situation. That's a good clarification. Not in this situation. Therefore, the two events are mutually exclusive because you cannot be on both. So we're going to find the probability that that if we picked an athlete at random, they were either on the basketball team. Now, can I say and swim team here? Why? Why does it have to be or? Because there's no and, right? No one's on both, right? And means they have to be on both. So you guys are right. We have to use or, swim team. Now, here's that word or. What do you think we do this time? Add. So probabilities can be written in three ways again. We've been writing them as fractions a lot. What are two other ways we can write probabilities? Decimals and percents. And in our case, they didn't give us the fraction. What's the probability that an athlete is a basketball player?
28%.
Yeah, which we can write as 0.28 if you want, or we can keep it the way they have it, 28%. Since it's an or, we add. Okay, Susanna, what's the probability we picked a athlete at random that's on the swim team? It can be a percentage. Sí, 23. You guys can laugh. My accent's so bad. Can I say trace? 23. Is that better? Yes, okay. I'll work on my accent. All right, so en total, ¿cuántos estudiantes? Is that right? Am I saying that right? Okay, good. I need to practice because when I go to Spain, I'm gonna be in trouble. How many? Do you have a different question? Okay, give me your hall pass. Perla. 51. That is 51. Is she right? Yes. 51. Cool? Or you add, and you multiply. So I hope you get those down. Mutually exclusive means they cannot have overlap. Now here's an interesting fact about mutually exclusive. Let's write the formula down for mutually exclusive. Mutually exclusive events. Since there is no overlap, what is the probability of A and B? And. Since there's no overlap, if we did like the sports team again, how many students are in sports team A and sports team B? 0. So mutually exclusive, if we're looking for and, it's always 0. But if we're looking for or, A or B, you add them. Probability of A plus probability of B. Okay? And you multiply or you add. And mutually exclusive, if events are mutually exclusive, there is no and. It has to be 0, since there's no overlap. Yes?
Would that be both 0 and 0%?
It would be 0%, yeah. Yep, exactly. All right, last one. For the probabilities that do have overlap, so probability of overlapping events last formula. Okay, another Venn diagram. This is an example of where we would see overlapping events. Example 4. I'm going to make this rectangle a little bit bigger. Better. Overlapping events obviously have to have some overlap. Are these two circles, the rings, are they mutually exclusive? Well, you actually can't tell yet until I actually put some values in. So let's put some values in and see if they're mutually exclusive. See if they actually have any overlap. Now, are they mutually exclusive? No, because which letter is in both circles? A is in both. So once you get one of them in one outcome in both, they're automatically not mutually exclusive. Okay? So, we have a bunch of letters here in our Venn diagram. How many letters are there total? 7. Okay? The probability of getting the letters F-A-C-E is what? 4 out of 7. The probability of getting the letters C-A-B, cab, is 3 out of 7. 3 out of 7. Okay, so if we allow this to be event A and this to be event B, what's the probability that we're doing, let's see, let me remember, A, that we get A or B? That we had all 7 letters in the bag, shook them up, pull it out, and that letter we pull out is either in circle A or in circle B. So you hear the word or, and what do we do?
Oh,
Add. Maybe. What's the probability of event A happening? Face. 4 out of 7. Plus the probability of B happening. 3 out of 7. Now, some of you guys are saying that's 7 out of 7, which equals 1. But face and cab, are those all the letters represented in the diagram? Are all the letters in the circles? No. So we should not have 100% chance of getting F-A-C-E or cab. Because there are 2 letters outside of circle A and circle B. What? Sure, but that would mean we'd only be looking at 5 letters, not 7, right? Okay, so we have an issue. I want to see if anyone picks it out. We've taken the letters F-A-C-E and the letters C-A-B, probability of face and probability of cab. Does anyone see a problem with just adding those probabilities? Probability of face and the probability of cab. Well, that is an issue, because we've already noticed 2 of the letters, D and G, are not in face or cab. So it shouldn't equal 100. Should it be more than 100 or less than 100? Okay, so mathematically, how do we get something smaller than 100? If we're at 100 right now, subtract and divide would both give us something smaller. So, let's go with subtract. Is there anything we need to subtract? Why would you subtract 2 7s? Oh, because you're saying there's 2 letters outside? Okay, look at the circles really quick. Once again, maybe I'll highlight, maybe that will help. We were looking at F, A, C, and E. Then we are looking at C, A, B. What's wrong with the way we've set it up so far? 4 7s plus 3 7s. I agree we need to subtract something. What do we need to subtract? Y, A, and C. Okay, they're in the middle. Can you give me more specifics? Look at how I color-coded it. What's happened? There's green and yellow, so what's happening with the letters A and C?
Oh, they're neutral.
Not neutral, they are being Overlapped, meaning how many times have we counted them? Twice. We've double counted. So we have to subtract away the double count. We have to subtract away 2 of them were in the overlap. Okay. And this is really nice. All the fractions have a common denominator. How nice of them. 4 plus 3 is how much? 7 minus 2 makes it 5/7. Or 72%, thank you. Okay, so here's the formula that we just did. When we have overlapping events, probability of A, or B, I should take away that little mark, is the probability of A plus the probability of B, but since they overlap, you have to subtract the overlap. Overlap, remember, is and. A and B. You have to subtract the overlap because, as the highlighting in the picture shows, we are double counting the letters A and C. Okay? Any questions? Independent, remember, means like rolling a die. My first roll has no influence on my second roll. Dependent would be like with my cards. I take a card, I put it on the desk. That changes my second drawing selection. So if you're changing your outcome on your second event, then they're dependent. Mutually exclusive means 2 circles, they have nothing in common. They can't both occur at the same time. Overlapping events, make sure you subtract the overlap. And is multiply, add is I said or is add, that's what I meant to say. And is multiply, or is add. Okay, so we have some time here to work on our assignment, which begins on page, I'm on the wrong section. Yeah, next week. After the SAGE test, I won't give you homework. You can when the bell rings. No, just during the week of the SAGE test. Okay, beginning on page 950. Numerals. This is fun, speaking Spanish. Where did I go to last time? Yeah, let's see. Oh, close. 11, 12, 13. Okay, they're laughing at my accent, huh? Was it in the return slot? And I graded it today during second period. Okay? So, I need everyone in their assigned seats, please. Excuse me. You need to be in your assigned seat.